Okay, what we're going to look at quickly now is exponential decay. This works in almost exactly the same way as exponential growth. Okay, so what we're going to, we'll basically talk about this again with an example. So let's say that you are a doctor and you've got some medicine, okay, and that medicine is an antibiotic. And we will say that for this particular antibiotic, for every day that you take the antibiotic, so for every day you take the antibiotic, the number of bacteria in your body halves. Okay, so every day that you take this antibiotic, the particular bacteria that it attacks, it halves every day. Okay, so this is an example of exponential decay. Exponential growth means the amount is increasing, it's growing. Exponential decay means the amount is decreasing, okay, it's decaying. All right, you would have heard decay when we talk about tooth decay, okay, that means your tooth is getting eaten away. We also use it in science when we talk about radioactive decay, and that means that an atom is, or atoms of an element are decaying, okay, they're changing from one radioactive form into a different element, okay. So for every day you take the antibiotic, the number of bacteria in your body halves. That means it's going down. Therefore, this is going to be exponential decay. All right, it works the same way as exponential growth. Okay, so let's say at the beginning, on day 0, okay, so when you go to the doctor, you've gone to the doctor because you're sick. All right, and let's say that on day 0 you have 100,000 bacterial cells in your body. Okay, so let's look at what we can do in order to turn this into a formula, okay, and then we'll look at what we can calculate. Okay, so on day 0 you have 100,000 bacterial cells in your body. Okay, for every day you take the antibiotic, that means that your time is going to be in days. The number of bacteria in your body halves. So we said when we were talking about exponential growth that n is equal to I times g to the power of t. This is still the same, okay? I is still, again, we will just refresh it. I is still your initial amount, okay? G is still your growth factor. And in this case, our growth factor is going to be a little bit different, but we'll talk about that in a sec. And t is still your time. Okay, now your initial amount in this case, we said that on day 0, that's the start, that's the initial moment. We have 100,000 bacterial cells in your body. So that means for our formula, we're going to have n equals, and I will be 100,000. Okay, now g is our growth factor. In this case, we said the bacteria in your body halves. Okay, so half is going to be that 100,000 times a half, so times 0.5. Okay, this is our growth factor. And then t just stays as t for time. Okay, so this is our formula. This is all it takes to put together a exponential equation. All right, we can now calculate things with this. So we can say how many bacteria are in the body after 4 days. Okay, and in order to do that, we just say n is our number of bacteria, is equal to 100,000 times 0.5 to the power of, and our t was 4. Okay, so if I calculate that on my calculator, 100,000 times 0.5 to the power of 4, you can do this using your calculator, and I get 6,250. So after 4 days, we have 6,250 bacterial cells left. After 4 days, there are 6,250 bacterial cells left. Okay, so this is an example of what you can do with this. Now, another type of question you are going to see, which is a little bit strange for these ones, is that they may say after how many days, after how many days, wow, I'm really terrible at writing today, will there be less than 500 bacteria? Okay, and now the textbook will ask questions like this. Okay, what they want you to do in this case, I'm going to use my fancy calculator here. They're actually doing this in a really silly way. Okay, because you guys haven't learned the strategies to solve these yet. Okay, and this will probably be helpful for exponential growth as well. So let's just delete all these lines. Okay, so we know that we have 100,000. And if you press execute, we have our 100,000. Now, if you times this by 0.5, and then press execute, or equals on your calculator, so that's 1 day. If you press enter again, it's done 2 days. If you press equals again, 3 days. 4, 5, 6, 7, 8. So after 8 days, and you can only do this using the calculator at the moment. Next year, when you get your graphics calculator, we'll show you how to do this using it. But for now, this is as best as we can do it. So this means that it's after 8 days. There are less than 500. Okay, and I'm not going to bother writing the whole sentence. Okay, so this is how they want you to do this. All right, so you just go on your calculator. I'll do that again just to make sure you guys can see it. So we'll start again. Delete all. Yes. Okay, so type in your initial amount. So 100,000. Press equals. Okay, multiply it by your growth factor. So 0.5 in this case, and press equals, and that's 1 day. And just keep pressing equals, counting how many times you do it until you have reached the value you're looking for. So that was 1 day, 2, 3, 4, 5, 6, 7, 8. At 8, we are under 500 bacteria left in the body. Okay? So after 8 days, we're under that. That's the strategy they want you to use for this for the moment. Okay? And that's it. All right, that's it for exponential decay.